Okay, this is for section 6.3, and this is called square root functions. And inequalities. And to be honest, I'm not really worried about the inequalities. It's just where they're taking the graph and they're shading one side or the other. We've done that with equations, so I'm not worried about that. Okay, and most of this we're going to do graphically, and I think you'll be able to tie this into what we did first semester when we graphed parabolas. Okay, we're going to do a lot of this on the calculator. So in y sub 1, we're going to put in the square root of x. So in on the calculator. Okay, put in the square root right above the x squared key, square root of x. And on the older black TI-83s and 83 pluses, the calculator puts that left parentheses, so you ought to close it with the right parentheses. On the new ones, I don't think it puts it there. Okay, so graph square root. Okay, and on this, let's just do zoom standard, zoom 6. Okay, and you should get a graph that looks like this. Now, is there a point at the origin? Yeah, and if you're not sure if there's a point, do this with me. Do right above the trace key, do second function calculate. Okay, and do value at x equals 0. As long as you see a y value there, 0, 0, yes, you know there is a point right there at 0, 0. Okay? Why is it not going into the negatives? Square root of a negative number? Square root of a negative number? Yeah, because you got some imaginaries, right? Okay, so that's why you're not seeing part of the graph come down here into the negatives, okay? Because of the imaginary. So it's graphing the real numbers, okay? Okay. This is the inverse. If you remember, go back on this one. We had first semester. We graphed the quadratics, right? Like y equals x squared. Y equals x squared looked like this. It graphed a parabola, right? Okay. Now it's graphing, instead of an x squared, we're graphing a square root. They are inverses of each other. Okay. So this is the inverse of the quadratic function, where we graphed parabolas first semester. Okay. Okay. Now, to make this a little bit better, I want to change the window. We don't need all of this on the left. Okay, so let's change our x min. I still want to see let's change it to -2. And let's change the y min to -2. Just go to window. And I really don't need that y max either, do I? Let's go to y max maybe 6. No, I don't need all that. Let's go maybe 4. Does that make it look better? Oh, wait a minute, I'm changing the wrong one. Sorry. Let's go x max 6. Let's go y max. Let's go y max 6. Let's see if that's better. Okay, we can see it a little bit better then. Okay. Okay, so then let's graph another one. What happens if this isn't in y sub 1, in y sub 2, let's graph a negative square root of x. Okay, so turn this one off. Okay, to turn this one off, you get your cursor on that equal sign. Right now, if it's dark, it's going to graph it. So get the cursor on the equal sign and press enter, and then go down to y sub 2 and graph a negative square root of x. Okay, and then graph it. We may have to change our window again. Nope, we can see it. Okay, I could go down a little bit on my y max, or y min, sorry. Let's go y min negative 4. Okay, so on this one, it's just going to graph it coming down this way. Okay, but you did learn to turn an equation on or off. You put your cursor on that equal sign and press enter. If it's dark, it's going to graph it. If it's light, it will not graph it. Okay. Yes, if you turn and put them both on, yeah, you can turn and put them both on, and it'll graph them both. Okay. It looks like a parabola that opens.
Testing all call system. Okay. Testing all call system.
Yeah, you could graph them both at the same time, and it'll look like a parabola that opens to the right. Okay. Okay. Now we're going to look at some patterns. Okay. Now that we've graphed a couple of them. Okay, we're going to go back in the first example. We're going to graph. I'm going to keep that y sub 1 square root of x and y sub 2. I want to know what happens if I take the square root of x.
Testing all call system. Testing all call system.
And then put a plus 1 on the outside. So on my calculator, I'm going to have the parentheses. So go down to y sub 2. Okay, clear that out. Then put in the square root of x. Close the parentheses. Now, you guys that are on the new ones, I think you have to use the right arrow, right, to get to the right, and then put a plus 1, not underneath the radical. Okay. Okay. Now graph both those. What does that plus 1 do to the graph? It did a vertical shift, up 1, right? And if you're not sure, do second function calculate value at x equals 0. Okay, there's the original. Now do the up arrow.
It looks like it's above 1.
But it's not. It's at 0, 1. It looks like it on the pixels because you're limited in the number of pixels. Okay, so for the first one, and leave this one and label it as y sub 1. And then this one, it's going to go up and label that one as y sub 2. Okay, now go down to y sub 3. Let's put in another one. In y sub 3, let's do the square root of x, and then out to the side minus 2. Okay, so do the square root of x, close the parentheses if you, or use your right arrow, and then minus 2. You would expect that that would do a vertical shift down 2. Okay, so go down 2, and does it cross? Yes, it does cross the x-axis, so it's going to go something like this, and that would be our y sub 3. Okay, so the effect somehow you need to say that this is a vertical shift. Okay, VS for vertical shift. This is a vertical shift up 1. This one is a vertical shift down 2. Okay. Okay, let's try another one. No, we're going to do a whole new one. Okay, now we're going to graph. Leave the y sub 1 alone and clear out the other one. In y sub 2 this time, what happens if we put a number in front? Okay, like 2. So clear out the y sub 2 and y sub 3 and put in the square root. We put a number in there, 2x. Okay, so here's the first one.
So this thing goes from 0.
Still starts at 0. Okay. So is that doing a vertical stretch? Okay. Let's try one more. Go down to y sub 3. In y sub 3, let's make it a little bit bigger. Let's do y equals square root. Let's make this 8x. So we need the square root of 8x. Yep. So graph those. This would be the original y sub 1. This one took it up a little bit higher. Still starts at 0. This would be our y sub 2. And this one goes up a little bit higher. Our y sub 3. It did not do a vertical shift. The VS, I guess I should say up here, this stands for vertical shift up. It moves the whole graph up. Okay, this one did a vertical stretch. Okay, stretched it. Okay, you just have to write it out. Vertical stretch. Okay. Okay, want to do another one? In y sub 1, leave the square root of x. This time, in y sub 2, put a number inside. We're going to do x plus 3. Put that all inside.
Testing all call systems.
Put that inside the radical. So clear out the y sub 2 and y sub 3 and put in the square root of x and then plus 3, then close the parentheses. Okay, so make sure you guys with the new calculators get the parentheses around that. Okay, and then graph. So we're going to have to change our window. Change our x min. Let's go x min like, let's go like -6. So what effect did that have?
Vertical shift left.
This one is actually a phase shift. Slide it left or right. Yep. Yep. This one would be a phase shift to the left 3. And that's just the opposite of what normally you would think. If you add 3, you're going to the right. So it's just the opposite of what you think it should be. Okay. Now in y sub 3, let's do the square root of x minus 1. Okay, and you can guess what that is going to be. Yeah. Square root of x plus 1. Oh, did I say? Okay, sorry. Yep, I need a minus sign. Thanks.
Do they cross?
They might intersect off to the right, but all I really want is that it's moving it. So this one is the original. And then this one, the plus 3 actually moved it to the left, right? And this one, the minus 1, moved it to the right. So this is the original, this is the y sub 2, and this is the y sub 3. Okay? So that one's a phase shift to the left 3. This one would be a phase shift. Phase shift is when you're sliding the whole graph left or right. So this would be to the right 1. Notice I'm not including the sign. The arrow tells you which way it's moving. Okay? Okay, so you should be able to tell a little bit on the graphs what effect those numbers are going to have on your graph. Okay? Okay, the next thing the author talks about on for a square root to be real. And by that I mean not imaginary. The radicand, and that's the part underneath the radical. The radicand cannot be negative. For example, square root of -5. You would end up with I radical 5, and that's not real. Okay? This would simplify to I radical 5, and that's not real, that's imaginary. Okay, so they will give you problems like this. They will say graph y equals the square root of 3x plus 4. And you have to pay attention, is that 4 underneath the radical or is it outside the radical? In this one it's underneath the radical. Graph it, and then they ask you to state the domain, range, and x and y intercepts. That's where it crosses the x and y axis, the x and y intercepts. Okay. First, to get your domain, okay, anything that's negative in there is going to give you an imaginary number. So it's okay to have 0 in there. So take that and set that equal to 0. It's actually greater than or equal to 0 because it's okay to have a positive number in there. Set it greater than or equal to 0. Subtract 4. 3x is greater than or equal to negative 4. Divide by 3. And x is greater than or equal to negative 4/3. Anything negative 4/3 is okay. Okay, greater than negative 4/3 is okay. Less than negative 4/3 is going to give you a negative number. So this helps to tell the domain. The domain is where x is greater than or equal to negative 4/3. Okay. Now let's graph it, and that will help us get our range. Okay, so go to your graph, clear all those out, and graph graph the square root of 3x plus 4. And you got to put that all inside the parentheses. Okay. And I'm going to do it in Zoom 10. Zoom, not Zoom. Sorry, Zoom 6, Zoom standard. Negative 10 to 10 and negative 10 to 10. Okay. Okay. Now, check. Do second function calculate. How can I tell where it's crossing there? Can I do it by 0? Let's see if it gives it to us. Can you get it to the left of where it's crossing? I don't know. Let's try it. I don't know if it'll do this. To the right of where it's crossing? It did. Negative, isn't that negative 4/3? Negative 1.3333? Right? Yep. Okay. Okay. I'm figuring out where this point is. Should be something like that. Okay. This is negative 1.333. The y value is 0. And doesn't that check? Isn't this negative 1.333?
How did you get that?
Okay, let me do it again. I didn't know, really, that's the first time I've done it where it doesn't come below the axis. So let's see. Try it again. Right above trace. Everybody do this with me. Right above trace, do second function calculate. Anytime it should be, like anytime you want to find the 0, and the zeros are the points where it crosses the x-axis. Okay, go down to number 2 on your calculator. They're called zeros or roots or solutions. Okay, so 0. It's asking for the left bound. Normally the left bound would be somewhere down here. Okay, so you got to get it to the left of that point. So as long as that's to the left of mine, and it is. Okay, press enter because it's off the scale, right? It's not giving you a y value, so you know it's not there. Press enter. Notice it marks it with a little triangle up above. On the new calculators, doesn't it give you a little vertical line? Straight up and down. Okay, to the right, get it somewhere to the right of where it's crossing. So somewhere up above, press enter. See my other triangle? It's saying find the 0 in between those two triangles. Okay, guess, just press enter. We could have guessed negative 4/3. Takes it a while. Okay, there's the negative. Okay. Okay, so that point is negative 1.333. And that's actually, you guys should actually put repeating, it's a bar above it, right? If you write it in, or you could write it negative 1.3 with the bar above it and then up 0. Brian, what'd you say? That is also the x-intercept. Now find this point. It needs the y-intercept, and we haven't found the range yet. Y-intercept, what's that x value? For this ordered pair. For this ordered pair, what's the x value? 0, isn't it? Okay, so do second function calculate value, number 1, at x equals 0. 0, 2, so it crosses at this ordered pair is 0 to the right and up 2. The only thing we don't have, we have the domain, which we got by figuring this part. Now, what's the range? Remember domain? Domain, we go left to right, right? So the x values are from negative 4 and 3, negative 4 thirds, and greater than that. The range, we start from the bottom up. What's the first y value? Yeah, 0, greater than or equal to 0. So the range, let's go one more. The range would be where y is greater than or equal to 0. Oh, I need to change this, sorry. This ought to be a brace. That's my fault. Okay, so there's 4 answers on there. The domain, the range, the x-intercept, the y-intercept, and we're done. Okay? Questions on that one? So if they say what's the domain, what do you do first? Set that radicand equal to 0, solve for x. Okay? And the rest of it you're basically going to do on your calculator. Okay? Okay? Everybody good with that?